Survey of algebra notes. This is 3.3. Solve inequalities using multiplication or division. So in our last section, we looked at solving with addition or subtraction. And today we're just going to continue that, and we're going to look at multiplication division. So the adding and subtracting was really easy because all we did is solve like we used to. We'd add numbers on both sides. We'd make sure to carry things down. And it was pretty much like working with an equal sign. With multiplication division, it's going to be a little bit trickier, and I'm going to take a minute here to explain why. So if I have something like 3 is less than, actually, let's make this -3 is less than 4. That's a true statement. And let's think about what happens if I multiply on both sides. So what happens if I multiply both sides by, say, a positive number? So what if we do 2 times -3? And we do 2 times 4. What happens? Well, on the left, I'd have -6, and then I'd bring down the less than sign, and then 2 times 4 is 8. So I still have a true statement, and that's what we want in math, right? So it looks like multiplying a number on both sides helps us maintain equality, so we don't have to worry. So what about if I multiplied both sides by a -2 instead of a +2? So -2 times -3 is a +6. I'd bring down my less than sign, and then -2 times 4 is -8. So when I get to the bottom of this, I have 6 less than -8, and our issue is that that is no longer a true statement. And so one of our differences then when working with solving inequalities is that because when I multiply or divide, it turns out, by a negative, I no longer have a true statement. I need to flip my inequality sign. So I reverse it here. Instead of a less than, if I write a greater than, now I have a true statement. So we're going to make a little note at the top. When multiplying or dividing, by a, and I want to erase this stuff and get it out of the way, by a negative, reverse the inequality. And I'm going to write sign because it's not the sides, it's actually the inequality sign we're going to reverse. So number one, I have a 2x. I am dividing both sides by +2 because I am dividing by a positive number. This one's easy. 2 divided by 2 is a 1. I have a 1x left, or x by itself, less than or equal to, and then 14 divided by 2 is 7. So because I divided by a +2, I could just bring down my less than or equal to sign, and there was nothing special to do. I'm going to go ahead and graph 6, 7, and 8. Remember, we want a number on both sides. And then this is a less than or equal to. So I fill it in to actually include the 7 because it's or equal to. And then less than is going to go to the left. All my numbers less than 7 go to the left. So we've been working a lot on graphing in the last couple lessons. And if you are confused, I would go back to 3.1. So the 3.1, we kind of do a better job of explaining that. Today, since we're reviewing it, the graphing is going to go pretty fast. So in the second one, I have a 5x. So if I have 5 times x, I need to divide both sides by 5. So -20 divided by 5 is a -4. Because I divided by a positive number, I'm going to leave this a less than sign and then bring down the x. Now my issue is that it's a lot harder to graph when x is on the right. We found that out yesterday. And so if I want to flip this inequality around, I also need to flip around the sign, because here the little alligator, remember we went back to like second grade inequalities and talking about alligators. The alligator is eating the x. I need to reverse that thing so that it's still eating the x. So then I'm going to graph -5, -4, -3, and then greater than means I am going to go to the right. So on 3, I want to divide both sides by -3. And because I'm dividing by a negative, now I'm going to reverse this and bring down the x, bring down the -7. So instead of a less than or equal to, I have a greater than or equal to, but I left x on the same side. The 21 divided by 3, that's on the same side. So because I divided by a negative, I had to reverse it. And now I want to rewrite this with x first. So then I'm going to have to reverse again, less than or equal to -7. So let's go ahead and graph. And then I need to make this a less than or equal to, so fill it in, and it goes to the left. On number 4, I want to divide both sides by a -4. So again, we are dividing by a negative. So it doesn't matter that I have negatives to start out with. It's that I'm dividing by a negative. So I divided by a -4. So because I am dividing by a negative, I want to reverse my inequality again. And so my x is on the left, and I have x greater than, and then here I have 3. So let's go ahead and graph that. 2, 3, 4, and then greater than is going to go to the right. Let's see, 5 and 6. So x divided by 3. So now we're looking at I have division to start with, so I need to multiply on both sides. So I'm going to multiply both sides by 3. And then I am left with x. Remember, when we divide by 3 and multiply by 3, it's just a 1x or x by itself. And then greater than. On the other side, 8 times 3 is 24. And then we want to go ahead and graph again. So we're going to put a number on either side of 24. So because it's greater than, I'm going to make an open circle because I don't want to actually include numbers at 24, just numbers really close. And greater than is going to go to the right. See, on the next one, I have a negative here, and x is being divided by 5. So I'm going to just rewrite this so I have a little more space. Because I am dividing by a negative, or because I have a negative, I'm going to multiply because I want the negative to go away. I want x to be positive, so I'm going to multiply by a negative and a 5 because 5 is what I'm dividing by. So I'm going to multiply by a -5 on the other side as well. So I'm left with x now. Negative times negative is positive. If I divide and multiply by 5, those are inverses. We're left with x. Because I multiplied by a negative, so let's make a little note here. Multiplied by a negative. That means I need to reverse. So this is now greater than or equal to, and 10 times -5 is a -50. So let's go ahead and graph this one, greater than or equal to. Okay, on the last two here for solving, I'm going to, let's see, divide both sides by -0.4 or -4/10. And again, divide by negative, so I need to reverse. So x is now less than. And I know 2.8 divided by 4 looks like a tricky math problem, but I can think of it as 28 divided by 4. So that's going to be 7 times. And so I'm going to put a 7 here, and then positive divided by negative is -7. And then let's see, -8, -7, -6. I'd have an open circle at the -7. It's going to go to the left. On the next one, I'm multiplying both sides by -2. And so we have x, multiplied by a negative again. I've got a reverse, and now this is a less than or equal to, and then -6. So I really like this chapter for the end of the semester. We're spending a lot of time kind of reviewing, right? We're reviewing kind of number lines and what those look like. We're reviewing solving, and then we're spending a lot of time right now actually reviewing translating as well. So we're kind of working on that vocab. So here it says the product. So product means multiply. Of tells me something's coming, and then the and is where that multiplication symbol goes. So this will be 10 times y, less than or equal to. Remember, less than is like an L kind of. You make it with your left hand, so less than or equal to, and the number 40. And then we're going to skip actually we are going to solve. We're just not going to graph. I think the solving we could do some practice on. So if I have 10y, I'm going to divide 10 on both sides, and then my y is less than or equal to 4. And I think I actually am going to graph this in case you wanted to try it on your own as well and just check answers. So I'm not talking you through it, but I will do it. Next, we say quotient. So on 10, so quotient means we're dividing. Of means something coming. Y and 12, so the division symbol is going to go where the word and is. So we'll have y divided by 12. And the easiest way to show that division is going to be with a fraction. And then greater than. So if my less than is like an L and I can make it with my left hand, greater than is the other way. And we have -1/3. And so because I have y being divided by 12, I need to multiply both sides by 12. And the cool thing is because I'm multiplying by a positive 12, I don't have to reverse my inequality. So it's just greater than. And -1/3 times 12, there's different ways to multiply that. Some people are going to be able to think in their heads, what is 1/3 of 12? And so sometimes if we think about it like with words, that kind of activates the language and math center of our brain, and we can kind of just come up with an answer by thinking without really doing any math. So I'm not going to spoil it and tell you what it is, but you might think in your head, what is 1/3 of 12? See if you can figure that out. The other way is that I could put the 12 over 1 and I could multiply straight across. So -1 times 12 is -12. 3 times 1 is 3. And that means my y is greater than -12 divided by 3 is -4. And I'm just going to kind of box it in there because it's busy. So the number that is 1/3 of 12 was just 4. And then because we had a negative, we had to make it negative. So this is the end of our 3-3 notes. Please let me know in class if you need any help or if you have any questions.